Hello world. Here, myself Subham Kumar, expressing my views on this golden topic during this corona pandemic, that is comparison of proactive and reactive routing protocol in mobile ad hoc network. Now, let's go straight to the detailed description of this point. Here we are going to discuss several points like classification of routing protocols, proactive and reactive protocols comparisons, performance matrices, and result in performance comparison of this. So let's go to the classification of routing protocols. Here the ad hoc routing protocols are classified into two types, that is the proactive, or you can say table driven protocol, and one is reactive or on demand protocol. So the proactive protocols can be further classified into OLSR, DSDV, FSLS and FSR. On the other hand, reactive protocols can be classified into AODV, TSR, AVR and TO. Now let's go to the technical comparison part of this proactive and reactive routing protocols. In proactive protocol, they have lower latency due to maintenance of routes at all times. In fact, they can result in much higher overhead due to the frequent route updates. Now, when a packet needs to be forwarded, the route is already known in proactive protocols. Now let's go to the reactive protocols. Like reactive protocol have higher latency since the route have to be discovered when the source node initiates a route request, and a lower overhead is experienced as all the routes are maintained only on on-demand basis, and it determines a route only when there is a data to send. Now let's go to some more points. Let's talk about latency of route discovery. In proactive protocol, there is no delay in the route determination as all the routes are maintained at all times. In reactive protocol, it shows a significant delay in route determination because of several factors that affect our employee flooding and traffic burst. Now let's talk about the overhead route of discovery and maintenance. In proactive protocol, it consumes more bandwidth as it contains the several maintained routes which are not going to be used in this process. In reactive protocol, it's get lower overhead since all the routes are determined on demand. That is at the time of communication the routes are maintained. Now let's talk about the trade-off between the traffic and mobility pattern of the both protocols. Like for reactive protocol, low traffic with high mobility is experienced, and for proactive, a high traffic with low mobility is experienced. Now let's go to the comparison part of this proactive and reactive protocols. Here in the picture you can see that the several types of proactive and reactive protocols are compared on the basis of several factors like scalability, reliability, load balancing and load flow. So that's it. Now let's go to the part of several performance matrices that we are going to use to compare the two protocols. Like the first of them is packet delivery ratio. A packet delivery ratio is calculated by dividing the number of packets received by the destination through the number of packets originated by the application layer of the source. Now the next point is average end-to-end delay. An average end-to-end delay is the average time it takes the data packet to reach the destination. This metric is calculated by subtracting time at which first packet was transmitted by source from the time at which first data packet arrived to destination. The throughput of the protocol can be defined as percentage of the packet received by the destination among the packets sent by the source. It is the amount of data per unit time that is delivered from one node to another via a communication link. So these were the several points from which we can compare our both protocols. Now let's see our result. Like we observed the average end-to-end delay of CBR traffic pattern for AODV, TURA and DSDV protocols, and then average end-to-end delay TCP pattern for the same. Now let's observe the average end-to-end delay for CBR traffic pattern. Here we plotted a graph between the average end-to-end delay and the number of nodes in the several routing techniques. Now, let's go for the average end-to-end delay in TCP traffic pattern. In this, we have done the same average end-to-end delay to purchase the number of nodes of the several AODP, TORA, TSDP routing techniques. Now, let's go to the conclusion part. Here, this study was conducted to evaluate the performance, reactive and proactive protocols based on both CBR and TCP traffic. These routing protocols were compared in the term of packet delivery ratio, average end-to-end delay and throughput when subjected to change in number of nodes. Simulation results shows that reactive protocol better in terms of packet delivery ratio and average end-to-end delay. Future work will to be evaluate the performance of these protocols by varying the speed pause time. The performance can be analyzed for other parameters like jitter, routing overhead. By evaluating the performance of these protocols, new protocols can be implemented or changes can be suggested in the earlier protocol to improve the performance. So that's all for this presentation, guys. Thank you.